Across the US alone, over 100 runways at 69 airports have a safety-critical system fitted to help prevent a major cause of aviation accidents: runway overruns. A study done in 2019 by Boeing showed that takeoffs and landings are statistically the most dangerous parts of a flight, with 49% of fatalities occurring at the final descent or landing phases. In hopes of reducing this number, engineers looked for ways to avoid this, and if you are as curious as I am, you have just landed on the right video. Welcome back to another episode of High Technology. Join the club as we unravel high-end technologies on the planet by subscribing to this channel and hitting the notification bell so you won't miss any exciting videos in the future. In this video, let's explore what seems to be the invention that has once helped the pilot but now became their worst nightmare. This is the EMAS, or the Engineered Materials Arrestor System. In essence, it is a special material bed that has been set up at the end of a runway to stop an out-of-control aircraft. The materials used to build the EMAS were selected for their ability to absorb energy and crush under the weight of an incoming foreign aircraft. Concrete blocks, which are dense enough to bring a jet to a stop after only a few meters. By doing this, both the possibility of injury and aircraft damage are reduced. The plane simply comes to a stop when its forward momentum is diverted into the substance. Overruns and runway excursions are particularly risky since they frequently result in the landing gear buckling, which can spark a fire. The EMAS is the ideal weight and density ratio to bring the aircraft to a secure, well-managed stop. Airports simply need to replace the precise blocks impacted by the out-of-control aircraft because the EMAS bed is designed to be modular. More crucially, the landing strip or airport can stay open the entire time. If the landing gear is not properly maintained and inspected, issues can still occur even during excellent landing conditions. Safran is one of the businesses driving the push in landing gear rehabilitation and repair. In addition to designing and producing top-notch landing gear systems, the business has done so for organizations like Airbus, Boeing, and When Safran technicians received an outdated or damaged landing gear system, they quickly put the components through a thorough 4-step process. The landing gear is taken apart and cleaned properly first. The components are then meticulously examined for wear or damage. For the best results, this is both done visually and digitally. The Safran crew then meticulously reconditions and manufactures each component. Then, much as with the initial construction, the protective coatings are reapplied. After carefully reassembling the whole landing gear system, the finished product may be confidently put back into the airplane. Naturally, not all airplanes lean in the same direction. You have the ability for vertical takeoffs and landings in the case of aircraft like the B-22 Osprey and F-35B. The U.S. Air Force Civil Engineers Center instructed its engineers to design a VTOL landing pad for an adjoint base McGuire Dix Lakehurst in New Jersey. In this instance, the engineers chose AM2 matting since it is frequently used in military applications. 4 interlocking edges from each pad can be linked to provide a variety of size landing surfaces. As a result, a landing pad that can be installed almost anywhere is created, which relieves pressure on airplanes and their landing gear. The United States Air Force also has some suggestions about how to successfully bring down an uncontrollable aircraft. The BAK-12 airplane arrest system has been deployed and improved here at Moody Air Force Base. This multi-disc rotational energy absorption device is comparable to the AFT component of the Cato bar system on an aircraft carrier. It comprises a cable that serves as an arrestor and crosses the runway. The cable is raised just a few inches from the ground by a number of rubber wheels that support it. An airplane can extend a tail hook to catch the wire if it is having problems or just needs to land quickly. As a result, the energy is transferred to a rotating mechanism, enabling a secure stop. The majority of airplanes aspire to never experience a challenging landing circumstance. Others are created with it in mind. Consider the Lockheed LC-130 as an example. This plane initially seems to be no different from a typical C-130 cargo. To better land on ice runways in the Arctic or Antarctic, this particular aircraft has been equipped with unique skis. 10 of these unusual aircraft, which were initially tested back in 1957, are still in operation today. Their main responsibility is to transport supplies and freight to isolated locations near the poles or in the American wilderness. This modified Hercules with a a carrying capacity of 42,000 pounds, is an excellent choice for the job. Its cargo bay is around 10 feet wide and 40 feet long. The A-10 Thunderbolt is unmatched by any other aircraft when it comes to difficult landings. The high position of the engines on the tail of this two-engine combat aircraft reduces the possibility of debris damaging the engines. The aircraft's superb mobility at low speeds and altitudes gives pilots more time to assess their surroundings before landing. Here in Poland, you can observe A-10 pilots doing stern landings and takeoffs on an extremely uneven runway. Despite being sluggish by today's standards, this 50-year-old aircraft continues to be a pilot favorite in the US Air Force. This appreciation is mostly due to the aircraft's remarkable range as well as its ability to land and take off practically anywhere. Its persistence, longevity, and distinctive appearance have even given it the label Warthog. The A-10 is a very powerful and excellent piece of equipment for the battlefield because it is built to carry massive quantities of bombs and ammo. It takes a lot of skill to properly carry off an austere landing, regardless of the type of aircraft being used. Fortunately, the AT-6 Wolverine, a potent trainer, is available to troops all around the world. The Beechcraft T-6 Texan is a single-engine turboprop fighter trainer used for anything from fundamental flight training to advanced maneuvers. This is the ARM variant of the aircraft. Because of its approximately identical wingspan to fuselage length, the AT-6 performs exceptionally well at low speeds. The AT-6 can take off and land in practically any situation thanks to this and its lightweight design. Its propeller-driven design means that it's accustomed to flying at lesser speeds and does not have to worry as much about ingesting debris. At Melrose Air Force Base in New Mexico, numerous AT-6 modified for landing can be seen doing so on an upgraded dirt runway. Lightweight trainers like these are likely to gain popularity as Air Force around the world search for new ways to operate more effectively and safely. In addition to being able to take off and land almost anywhere, they also cost less to run than their big jet-powered competitors. EMAS has been installed on 68 airports and 112 runways as of 2019. At 2 additional US airports, there have been proposals to install 3 further systems. Funny enough, some pilots choose not to use the EMAS in order to prevent negative press. In such a case, they would steer to the grassy side of the runway rather than employ the system. And that's a wrap for today's video. Do you think there's anything even scarier for pilots to face? Let us know in the comment section down below. If you enjoyed this content, please don't forget to like and hit the subscribe button and turn on the notification bell so you can always get to watch more incredible videos like this. This has been High Technology, serving you the best and cutting-edge contents on the highest form of technology available on the planet. Until then, see you.